So now this question is about कि वो कह रहे कि large number of isomers with the formula, and the formula is CrH2O6 Cl3. They exist, and their general formula is this thing. And each isomer contains 6 coordinated chromium 3 ions in an octahedral complex. What they mean is that the chromium is surrounded by, if I can write over here, just 1 second. So what they mean is that the chromium is surrounded by 6 water molecules, and it's a 3 plus ion. Not 6 water molecules, but this is the complex right over here. This thing is the complex. So it's surrounded by either 6 water molecules and 0 Cls, or it could be a combination of the two. It could be three. There's an N written over here, so it could be 3 water molecules, 3 Cls, or 1 water molecule and 5 Cls. This Cl over here, this one over here has nothing to do with the complex. This part is the complex. The Cl is outside the complex. So the question then states that water molecules not directly bonded with the Cl atom are held in the crystalline lattice as water of crystallization. The CrCl bond is not easily broken, and so the chloride bonded with the Cr3 ions in the complex does not react. So, so these ones are not going to react. I mean, let me make a line with this one. These ones over here, their bonds are not going to break. So it's the outer ones. These are the ones that are actually going to take part in the reaction, and they will be reacting. Now, coming back to the question, so the chloride bonded, so 1 gram sample of the 3 isomers A, B, and C were dissolved in separate samples of water, and excess of silver nitrate was added. Now, silver nitrate forms a precipitate with Cl ions. And with Cl ions, remember, it's not the complex. They've already told us in the question that the Cl that are part of the complex, which is stated over here, that the CCl bond is not easily broken. So the ones that are part, so chloride bonded with the chromium 3 ions, they do not react. So these ones are not going to react. So it's the outer ones that are reacting. So in this reaction over here, which Cl is taking part? It's the outer one, the one that's over here. So they've given us 3 complexes, and they've given us the moles of those 3 complexes. So the first one has, and let me write the complex. So the first one has 3.75 into 10 power minus 3 moles of AgCl. So if you have 3.75 into 10 power minus 3 moles of AgCl, you also have 3.75 into 10 power minus 3 moles of Cl ions. So if I just look at the first one, and let me write this over here. This is the formula. The formula is Cr with H2O, and that's 6 minus N, I guess. And you got Cl, which is N. That's your complex. And then you've got Cl's outside. That Cl is that outside Cl is 3 minus N. So you got these outside Cls. That's 3 minus N. So what we have figured out is we figured out about this outside Cl. We figured about this one. We figured out that this is what? This is 3.75 into 10 raised to power minus 3 moles. So we figured that one out. And what else we have figured out is that what else have we figured out? I mean, let me write the full formula as well. The full formula is there's an NH2O as well at the end. Now, in the first part, they did ask you to calculate the amount of this thing. So H2O6. Remember, it's going to be H2O6 because it's always going to be H2O6 because if there's 5 H2Os, that means N will have a value of 1. The other one will be 1 H2O. So it's always going to be 6 H2Os. If Cl is N, over here Cl is 3 minus N. So the total Cls would always be 3. If you add this with this, it's always going to be Cl3. So that's why they gave you the MR. And they told us this entire thing has a mass of 1 gram. So this entire thing has a mass of 1 gram. The whole thing. The whole thing has a mass of 1 gram. So I can find the moles. It's going to be 1 grams divided by the MR, which is 766.5. And for this, I would need the help of my calculator. So, X can you call it? So 1 divided by 766.5, I guess. And that gives me 0.01304. So 1 divided by 766, and that is 1 gram. They told us that the isomers, they have a mass of 1 gram. So let me try and calculate the MR again, just very quickly. Cr H2O6 and Cl3. I guess that is correct, 766.5. So that's giving me 0.001304. Okay, so this one is actually 266.5, not 7. So let me correct that. That's 1 gram divided by 266.5. So we're going to do that now. 1, and that's going to be divided by 266.5. Now I'm getting 0.00375. So I'm getting. So this is the value that I'm getting. That's so this thing gives me a value of 3.75 into 10 to the power minus 3 moles. So what's the ratio? The ratio is that when you have it's 1:1. That means when you have one of this, one molecule, you've got 1 Cl. I mean, that's the ratio. This is what that means. That if I have 3.75 into 10 to the power minus 3 moles of this entire thing, I've got how many Cls? I've got 3.75 into 10 to the power minus 3 moles. So it's the same ratio. So if I have one of this entire thing, so one molecule or one complex ion or one crystal of this is going to have 1 Cl. That's the ratio. So the Cl over here is going to be 1. For that, the N is going to be equal to 2. So N would be equal to 2 in this case. So the value of N for the first one is going to be 2. Now the next one is, they've told us that the Cl, this outer one, that's 7.5 into 10 to the minus 3. So if I take this as 7.5 times 10 to the power minus 3, so what ratio is this? That if I have one of this entire thing, I mean 3.75 ratio 7.5, that's I think 1:2. So that means one molecule has 2 Cls. So if you want 2 Cls, the value of N is going to be, it's going to be 1. So in this next one, the value of N is going to be 1. And the last one is, so the last one is 1.13 into 10 raised to the power minus 2. So that I think, so it's 1.13 times 10 raised to the power minus 2 moles. So that means that if I have, it's I guess 1:3. I think if you can try multiplying this, that's 1:3. So if I have one molecule of this, I'll have 3 Cls. That's the ratio, 3 Cls over here. So that means the value of N is going to be 0 in this case. And you can write down the value. You can write down the formula yourself. You just have to plug in the values of N. So the first one was, I'm going to repeat this. They told us that there was 1 gram of this crystal, right? So I took that 1 gram, divided it by its MR, and I found that this entire thing has these many moles. They told us that the AgCl, we were able to figure out the Cl lines. The Cl lines were these ones over here. So, so I figured out in the first one, you're going to have 3.75 into 10 to the minus 3 moles. So if you have 3.75 of this entire thing and it contains 3.75 of this, that's 1:1. So that means one of this is going to contain 1 Cl, right? So N is going to be 2 in that case if you want 1 Cl, and so on.